In this video, we will look at the Aldol reaction and Le Chatelier's principle. The classic Aldol reaction involves an aldehyde reacting with sodium hydroxide to give an intermediate enolate, shown here in the brackets. That intermediate enolate then goes on to react with another molecule of aldehyde to form the new aldol product with the bond that I'm highlighting here in blue between the two reactants, the enolate and the aldehyde. If you look at the first step of this reaction where we form the enolate, you'll notice the equilibrium constant is about 10 to the minus third. This is pretty small, which means we have only a small amount of enolate present at any one time during the reaction. So the question might be, if there's very little enolate formed from this first reaction, why would we expect to get very much of the aldol product over the course of this reaction? The answer lies in Le Chatelier's principle, wherein if we make a change to one side of an equilibrium, either on the product side or the reactant side, the product amounts will shift to compensate for that change. So if we walk through the reaction again, we see that the aldehyde reacts with sodium hydroxide to give an enolate. The enolate then acts as a nucleophile, adding to the aldehyde electrophilic carbon, and following proton transfer gives us the aldol product. What this means is that even the small amount present of the enolate, regulated by the equilibrium constant here, is enough enolate to have the reaction proceed such that when enolate is consumed, it is replenished through this equilibrium. So Le Chatelier says that if we remove a product of an equilibrium event, more of that product will be formed to keep the balance based on the equilibrium constant.